Now on to the 5th chapter of A-levels physics, which is energy, work, energy, and power. And the first module is energy conservation. First thing you need to understand here is the concept of work, which is the measure of, in exams, you just need to write the products of force applied and distance moved in the direction of force, right? But to understand work a little bit more, I think this definition is a bit better. The measure of energy change, right? This is a keyword, energy change. Energy change that occurs when an external force displaces an object in its direction, right? And the formula for work is F into D, right? Where F is the force applied and the distance, D is the displacement from its original position, is equal to work. And the unit is joule, right? Now, the reason the unit is joule is it is a measure of energy change, basically. So what that means is, for example, if an object is moving, right? Moving with a certain velocity and a certain mass, you know that it has a kinetic energy equal to 1 over 2 mv square, right? So let's just say 1 over 2 mv square was 50 joules. Now later on, a force is applied here, and the energy and the new energy of this object becomes 60 joule. So the work done on it is now 10 joule, right? Positive 10 joule, because the energy is increasing. And if another example is to be taken here with the same thing, for example, the same thing, 50 joule energy again, but a force is applied in this direction and it causes velocity of this to decrease and the energy to become 40 joules. So the work done on this system was negative 10 joule, right? Because 10 joule was taken from this. Or you can just write 10 joules for all your purposes. This will be fine. But it's just a concept that you need to know that work is just the change of energy of a system, right? And we're going to do some examples when we discuss power. So you'll better understand this. Now, conservation of energy. I think we all know what I'm going to say. Energy cannot be created or destroyed, but changes forms. I think we all know this, but still I'm going to explain this a little bit. For example, if the best example for this is an object falling in a vacuum, right? Its gravitational potential energy is being converted to kinetic energy. So that is the perfect example here. And let's just move on now. Now, efficient output and percentage efficiency. Now, efficient output is output energy or whatever, right? Output power, output energy, whatever. Input energy, right? So what you are putting in and what's coming out. And this is the ratio, basically. And if you multiply this by 100, you get percentage efficiency, right? So this is just efficiency of the system. Efficiency. And if you multiply this by 100, this just becomes percentage efficiency, right? Now on to power. So there are two formulas for power in your syllabus. The first one is the simple one, is which is power is equal to work done over time or delta energy over time, right? We discussed that work is just change of energy. So these two formulas are the same, right? And the definition would be work done per unit time or rate of work done, whatever suits you. It doesn't matter. Now an example of this would be a moving turbine, right? So for example, there's water, and this is a turbine, right? I'm just going to draw a rough diagram here, right? So the water is moving in this direction with a velocity of 20 meters per second. There's some work done on the turbine, and here the water is moving at a speed of 10 meters per second, for example, right? The mass of water in unit time, right? For example, in 10 seconds, 100 kg of water moves across here. So calculate the power, right? So first, we will measure the work done, right? We know the time, but how would we measure the work done? It's the kinetic energy, right? Subtracting the kinetic energy. So 1 by 2, 100 multiplied by 20, right? This is energy before, energy after. You should just do before, after, but whatever, right? Sign doesn't matter here because, yeah, sign doesn't matter here. Now this just comes down to 500 joules, right? So the energy difference between the water here and the water here is 500 joules. So the power would be delta energy, which is 500 joules, and time, which is 10 seconds. So this becomes 50 watt, right? The unit of power is, which is a derived unit, SI unit is watt or W, right? Now moving on to a new formula, which is P is equal to FV. Now you need to understand that the force is here is driving force, and the velocity is constant. This is very important. Whenever they say there's a constant velocity and a driving force, you should always think of this formula first, right? For example, this is a car. Pardon my very bad drawing of a car, right? This is a car, whatever. And its driving force is 500 Newton, for example. And it is moving at a constant velocity of 10 meters per second, for example, right? So the power for this one would be 500 times 10 and becomes 5,000 watt, right? So this is another definition of another formula of power. You're going to need to use this in some MCQs and even some P2 questions. So you should remember that. And the key word is constant velocity. Whenever you hear the word constant velocity, you should always think of this formula as well, right? So this is it for this one. I hope you enjoyed and learned something, and I'll see you guys in the next video.